All right, this final lesson on applications of exponents, I'm actually going to split into two lessons. This is going to be the first part of it. We're just going to go through the first couple examples here. So starting with the first one, light travels approximately 5.87 times 10 to the 12th miles in 1 year. This distance is called a light year. Suppose the star is 2 times 10 to the 4th light years away. How many miles away is that star? So what we're going to do is the light is traveling 5.87 times 10 to the 12th miles per year. And that's 1 light year. And this star is 2 times 10 to the 4th light years away. So in order to multiply these, we're going to figure out how many miles we're going to get. So again, 5.87 times 2. It's going to give me 11.74, and I'm going to get times 10 to the 16th. So this is not in scientific notation, so move it to the left 1. So I get 1.174. That's a loss because it's to the left, so my exponent is going to gain 1 then. In example number 2, find the volume of a rectangular prism with these dimensions. So if I'm finding volume, remember I'm just doing length times width times height. So here I'm going to be doing the whole parts, so 1.3 times 1.5 times 9.4, and that's going to give me 18.33. I need to do my 10 parts, so I have -3, -3, and a -4, so that's to the -10th, because I'm simply adding my exponents together. So the first part of this is not in scientific notation. I need to move the decimal point there. So 1.833. Moved it to the left, so that was a loss. Over here we're going to gain. So this is just going to be to the -9th, and it's all kilometers, so kilometers cubed then for our answer. So number 3, all objects, even resting ones, contain energy. A raisin has a mass of 10 to the -3 kilograms. So this expression, 10 to the -3rd times 3 times 10 to the 8th squared, describes the amount of resting energy in joules that a raisin contains. So we're going to go ahead and simplify this expression. We're going to take care of this squared first. So I'm going to get 10 to the -3rd times 3 squared, which is just 9, times 10 to the 16th. So I'm going to get 9 times 10, and I can put those two together because they have the same bases, which is going to be 9 times 10 to the 13th joules per raisin. Exciting, right? An hour of television consumes 1.45 times 10 to the -1st kilowatts of electricity. Each kilowatt hours of electricity use is equivalent to 3.6 times 10 to the 6 joules of energy. So simplify using the above information to find out how many joules of television uses in 1 hour. So basically this is 1 hour, this is how many joules, so we're multiplying here. So we're going to be doing 1.45 times 10 to the -1st times 3.6 times 10 to the 6th. And when we multiply those numbers, we get 5.22. 10 to the +5th joules per hour. So then it says, suppose you could release the resting energy in a raisin, about how many hours of television use could be powered using that energy. So this is how much we get, how much it takes per hour to run the TV. So we're actually starting out with this many from a raisin, and we want to know how many hours of TV we could actually get out of it. So in order to do that, we're going to do the raisin energy divided by part A. So we're going to get 9 times 10 to the 13th, which is the energy contained in a raisin, divided by 5.22 times 10 to the 5th, which is how much it takes per hour. So we are going to get 9 divided by 5.22 is going to give us 1.724, so we'll say 1.72. 10s times 10 to the 13 minus 5 is 8, so 1.72 times 10 to the 8th hours would be our answer there. So that's the first part of this lesson. The next part I'm just going to go ahead and do. So the last couple examples here. In number 5, it says in the year 2000, the total amount of glass recycled in the United States was 2.7 million tons. The population of the United States in 2000 was 281.4 million people. So million has 6 zeros. So 281.4 times 10 to the 6th is how we actually represent millions. So this one is 2.7 times 10 to the 6th here. On average, how many tons of glass were recycled per person? Use scientific notation. So this number actually is not in scientific notation. We actually have to move the decimal 2 places to the left. So we get 2.814. Since we lost it 2 places here, this is going to gain it. So it's going to be times 10 to the 8th. So we want to know glass per person. So here's the glass recycled. So 2.7 times 10 to the 6th. And we're going to divide it by the number of people times 10 to the 8th. So if we do 2.7 divided by 2.814, we get 0.9594, so we'll just say 0.959 times 10 to the 6 minus 8 will be negative 2 power. Not in scientific notation, so we do need to move it to the right one, 9.59. Since that's a right, that's a gain, which means this side is going to have to lose. So we get 9.59 times 10 to the negative 3rd tons per person. Number 6. Earth has a radius of about 6.4 times 10 to the 6 meters. Approximate the surface area of the Earth using this formula. So surface area of a sphere is 4 pi r squared. So our surface area is going to be 4 times 3.14 times 6.4 times 10 to the 6th squared then, just by plugging that into the formula. So 4 times 3.14 is going to give us 12.56. 6.4 squared is going to give us 40.96. And 10 to the 6th squared is 10 to the 12th. So from here, we're going to multiply these two plane numbers together, and we're going to round off to 514.46. So that's that times 10 to the 12th. Not in scientific notation. 2 to the left is our loss, 5.1446 times. So that's a loss of 2. This will gain 2. So 10 to the 14th meters squared, because we're talking about meters and we're talking about surface area. So for our purposes, let's just round this off. So we're going to say 5.145 times 10 to the 14th. So Earth's surface is about 70% water. So about how many square meters of Earth's surface are covered in water. So we want to do 70% of the 5.145 times 10 to the 14th. So 5.145 times 0.7 is going to give us 3.6015 times 10 to the 14th. And that's meters squared. And in part C, the oceans have an average depth of 3,795 meters. Estimate the volume of water on Earth. So this is our surface area times our depth will give us our volume, because your area, your length times width times your height, essentially. So this number right here, 3.795 times 10 to the 3, loss of 3, so gain of 3 then. So we're going to take that and multiply it by 3.6015 times 10 to the 14th, and we're going to end up with, round off here, 13.67 and 10 to the 17th. Not in scientific notation, so a loss of 1 moving to the left, gain of 1 in our exponent then, and that's going to be meters cubed for the volume. All right, number 7. 1990, government owed 3.23 trillion. So trillion is going to have 6. It's going to be to the 12th. So just to kind of help you out, 10 to the 6th is going to be million. And 10 to the 9th is going to be your billions. And 10 to the 12th is going to be your trillions. That kind of helps me just kind of have as a side note. So 3.23 times 10 to the 12th is trillions. Population of the United States was 248.7 million people. So million would be times 10 to the 6th. But we need to move 2 to the left, so this is going to gain. So 2.487 times 10 to the 8th. How much did the government owe per person? So we had 3.23 times 10 to the 12th. So money per person. So 2.487 times 10 to the 8th. And if we divide that, we get 1.3. 10 to the 4th. So if we go ahead and actually make that money, we're going to be moving our decimal point 4 places. There's 1, 2, 3, 4. So there we go. $13,000 per person. And that was back in 1990. In Part B, in 1999, the debt had grown to 5.66 trillion with a population of 273 million. How much did the government owe per person? So 5.66 trillion, which is going to be times 10 to the 12th, divided by 273 million, so 2.73, loss of 2, so gain of 2 for the millions, and this gives us about 2.07, and 12 minus 8, 10 to the 4th, so 1, 2, 3, 4, so $20,700 per person then. Percent of increase in the average amount owed per person from 1990 to then. So we're finding the difference between 20,700 minus 13,000, which is going to give us a difference of 7,700, which we then divide by the original, which was back at 13,000, which gives us a 59% increase in the debt cost per person.